Hi guys, Jimmy here from NCTU. Today I'm gonna show you guys how to draw a lens of lunginous on ANSYS SpaceClaim. So this is the final work of our project, just to get a peek view. So the first step is to draw this spiraling handle. I'm just gonna hide this finished work here. So the first step is to draw the handle, right? So the first step is to find a plane that you want the handle to lay on. For me, I'm gonna select the XY plane. Just click the Z axis and your sketch will be laying on the XY plane. Then we have to draw a line, a straight line, for our handle, for our spiral to have a axis to spin on. Then select a circle. You can move the circle away from the pivot line or close to the pivot line. It depends on you. But for me, I would choose to move it away from the pivot line because I wish my spiral to be decreasing. The curve of the spiral will be decreasing and towards the end, and the front of the lens of lunginous will be right here. So the spike will be right here. And the next step would be copy and pasting this circle towards on the other side. So the first step is to measure how far is your circle to your line. So you click on measure and click measure, press Ctrl and select your circle and select your line. So this gives a distance between between your circle and your line, which is 1.13 millimeters. So now you know how far should your other circle be. Oh, and there's another step. Here I might split my circle in half just to make the outer shell of the lens of lunginous to be more ribbon-like. And from the measure tool, we already know that the distance between this circle and this line is 1.13. So we have to move this half of the circle 1.13 millimeters plus the radius of this hemisphere. So we click on this hemisphere and then click on the green axis and type on 1.13, and then we type again 1.13, 1.13, and now, and I guess the distance is not 1.1, it's not 2.26, but I'm just gonna measure it. Press Control, and the minimum. So the minimum distance between from the center of the circle to the line is 1.13. So it has to be moved one more radius, a distance of one more radius. So we click on Measure and click on the hemisphere. So the arc length, so the radius is 0.2236. So we have to move 0.2236 on the positive y direction. .2236. Okay, it doesn't let me move it at 0.2236. Okay. Now I think it's now symmetric. .3536, and the other one is 1. Oh my god! I think there are some errors in here. So the distance between this hemisphere and this line is 1.13, and the distance between this line and this line is 1.3536. So it's 1.3536 minus 1.13. So that equals 0.2236. So this hemisphere has to be moved to the negative y-axis with a distance of 0.2236. So I think there are some calculation errors. So negative 0.2236. Okay, that is symmetric. Let's measure it again. Okay, the distance between this line and this line is 2.2236, and we know that the distance between this line and this line is 1.13. So these two hemispheres are perfectly symmetric. So the next step is to create a spiral. So how do you create a spiral that has different pitches and different spiraling angles? So the first step is to click on Pull tool and select a hemisphere. Select a revolving tool, and then click on Options. And then click on the axis that you want your object to revolve on, and then you click on Options. Then click the Revolve Helix. So you can see that there's height, pitch, and taper angle. So it is just a trial and error process. So I'm gonna try with a taper angle of 8 and a height of 10, maybe. Okay, that is what I want, but I'm hoping that okay, never mind. This is what I want, but maybe the pitch can be smaller. So Control Z. So I'll change the pitch to maybe like 2.5, and the height is the same as before, 10. Okay, so we'll do the same thing as this to this hemisphere. So select your hemisphere. So click on the Pull tool, and then click on the Revolve tool, and click on Options, Revolve Helix. and we hit on 10. Yeah, that is correct. So our pointy part of the Longinus lens of Longinus will be facing this way, and the handle part will be facing this way. So the next step will be extending the handle. So how do we extend the handle? It's same as before. We select the face that we want to revolve and an axis that we want to revolve on. But this time we have to change the pitch and the height, and maybe the taper angle. So I'm just gonna do some trial and errors, like 30, and the pitch would be, oh, that is definitely not expected. So I think the taper angle should be negative, and the height would be like 30. Oh, should be negative 30. Ah, that is correct. So we have to undo this part of the handle. So I'm gonna change the pitch to why isn't it responding? I'm gonna change the pitch to like 8. Right, 8, and the height would be negative 30. And no, this is a process of trial and error. So the pitch would be like 2, and the taper angle would be negative 2. The height would be negative 10, just for a try. I think I get it. So I'm gonna change the height to negative 30, just to get a longer handle, like this. And we'll do the same thing to the other part of the handle. Select the face, select the axis that you want to revolve, and then the height would be the same as before, negative 30. Okay, it's not responding, but I'm gonna just do it again. Select the face, and then select pole, click on options, revolve helix, and click in negative 30. Okay. So there are some strange parts here. So if you're later on doing a simulation, it is strongly recommended that you discard this part, because these parts might affect your mesh strongly and create great skewness in your mesh. But if you are just using SpaceClaim as a drawing device, it is okay. I think I'll change the pitch and the height more. I just undo what I did before. Click on pole, click on face, click on axis, click on pole, click on the axis, and then click the face, options, revolve helix. So we're going to change the taper angle to, let's say, -1, and the height would be -30, as always. Maybe I'll change the taper angle more smaller, or the pitch smaller. Like pitch would be 1, the taper angle would be 0.1 or 0.5, and the height would be negative like 50 maybe. And no. -0, -1, and -40. Okay, so we'll do the same thing to the next face. Select the face, click on Tool, select the face, and click the revolving tool. Then select the face, click on Options, Revolve Helix, -40. Okay, so this ends the first part of our lens of Longinus drawing. I hope you like it. And the next part will be handling the pointy part of the lens of Longinus.